T equal to 0. Okay, this is soap film. Soap bubble, I'll write it. Outside also, it'll be present. So first, directly get into what is the pressure. Outside atmospheric pressure is P naught. Surface tension, anything? Okay, not there. Okay, we'll write it. P equal to P naught plus St into capital R. Now with the time, what will happen is the pressure is more inside the bubble than outside, no? So therefore now the air what happens starts rushing it here, or you can compare your pressure here P naught. Here air will be present, P naught, or even the air what happen will also be here. So will be P naught, here P. So the air starts flowing, no, from higher pressure to lower pressure. So as the air starts flowing, what will happen to bubble? The bubble starts collapsing. So that's what he's asking. Estimate the time interval taken by another bubble of radius. Okay, I think, okay, if the closed end is open, when I close it, no, okay, it will be there, that one. So if the closed end is open, the bubble collapses in a time interval delta T naught. So how much of time the bubble will take to collapse? Delta T naught means the air what pen will escape. So as it escapes what pen, the bubble what pen will take shape like this, then, and finally it will be. So one more small diagram. If you can understand the sequence, it'll be easy for you. So it will be initially like this. After some time, and after some time will be like this, will keep on collapse as it does like this. So the air water pen will rush here. The air will rush here. Let area of cross section of this, let it be A. The bubble, okay, that particular thing. So what is the size of the bubble? The radius of the bubble keeps on decreases. I think I can help you diagram only this one. More than this, not possible for me. So what is the pressure here? P naught. The pressure here, let it be P. Area of cross section of this, let it be A. Moving air. Fine. Okay, now what to do now? That time is asking how to bring that time. So what happened to volume of bubble? Volume of the air inside the bubble. Volume of the bubble will decrease, no? So let the radius be R. So let's get into the mathematics. Volume of the bubble equal to 4 by 3 pi R cube. So what all amount of air that is decreasing in the bubble, that particular air will rush through the open end. The moving air, I'm putting this one. So the amount of air decreasing in the bubble should be equal to amount of air that is coming from open end per second. So shall we use conservation of mass principle? So here, rate or say amount of air decreasing in bubble is equal to per second is equal to amount of air rushing through open end per second. So this should be equal to rho into change in volume dV by dt. Okay, this I think there are. So shall I use U here because we will be using for volume. So dV by dt is the volume here, rate of change of volume, density into rate of change of volume. What shall I write here? Rho into flow rate. Flow rate, density into flow rate will be the rate of mass, no? It should be. So area of cross section into U. So we have equation. So I'll differentiate this dV by dt. So this will be 4 by 3 pi 3 r square dr by dt. What will happen to radius? In fact, it decreases. So shall I go for negative sign? Why negative sign? Radius of bubble decreases. Okay, no. So let me substitute here dv by dt. Rho get eliminated. So this will be 4 by 3 pi 3r square minus dr by dt a into u. Okay, somehow I have brought equation. Let's apply Bernoulli's theorem between these two, inside the bubble and at the open end. Okay, applying Bernoulli's theorem. In the bubble and between bubble, in the bubble line between, I should write, no? Applying Bernoulli's theorem between between points, okay, points inside the bubble between the point inside the bubble and open end. Okay, what is the Bernoulli's theorem? What is the pressure there? P. What is the so the air starts rushing here. So what we can take this one? This will be a test. So P is equal to outside pressure there, P naught plus rho U square. Okay, substitute. I think let me give all the number 1, 2, 3. Substitute, put 1 in 3. Let me keep it here. This is. So I'll okay, the initial background is what? We have made it. Okay, now I'll come for this one. From 193, so P naught plus 4 st by r is equal to rho u square by 2. So with this, I'm getting expression for speed of the air. So this will be 8 st by rho r. Call this equation any number. Okay, still our question is what, like time taken, no? How to bring that time taken for. I think the dt is available here. You can see the equation 2. This is what I'll put. Now 4 into I'll substitute because dt is available. So I got expression for this. So 4 by 3 pi 3r square a into this will be u will be 8 st by rho r. Okay, I think 1 3 we can eliminate it. So what all we get? R to the power of 5 by 2. R to the power of 5 by 2 dr equal to minus a by 4 pi initially r, finally 0. This is time. Anybody just solve it and give the final answer, delta T naught. Okay, the dt is what? That we have taken up here. R to power of 5, no? So this will be, I think, 4 pi. We wanted T, no? Okay, let it be. I'll write down the 4 pi A will come. 4 pi A rho 8 st. What are other things? R to power of 7 by 2 by 7 by 2. Can we write it? Final expression 8 pi anybody final equation? Okay, this 2 will be there, no? Just simplify, give me final answer one. 4 will come. 4 pi a rho 2st. 7 will be there here. 7a r to power of 7 by 2. Okay, check it.
It will be 2 pi, sir.
2 pi, huh? No, from here 1, 2 will come, no? 8st. Root 8 is there, no? So root 8, I'll take 1, 4 outside.
Okay, sir.
Huh? Yeah, that one. Okay, now you compare when the radius becomes r to eta r, then it's asking what can be the relationship. Okay, there's a one problem, very important. The bubble will not collapse. It will collapse gradually. It will, in fact, it will take some time. Okay, can you work out the other part? If telling eta r, some relationship is asking. Okay, let me do one more. The same. I think this question I discussed in class. I do remember. Okay, well, anyway, it's related to thermodynamics. Very important. Advanced exam, when you go, no, please do revise. Especially you see surface tension, no. Every year there's a one question. Every year, he never stopped asking good question from surface tension. Until now, they didn't ask with thermodynamics. They've asked all other things till now. So possibility of asking. Is asking molar capacity. Directly will go for the formula. What is the molar capacity formula? C is equal to CV plus PdV by RdT. Okay, I'll make you to recollect.